The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Okay, there we go, got the pointer boy. Example, force of tension 7. A net upward force of 7 newtons is on the chin of the injured patient. What is the force of tension on the strap? Tension is consistent throughout the strap. Well, looking at this problem firstly, right? This is going to be entail Cartesian coordinates, right? Because it's going to be a vector problem. Now, we can go ahead and call upon the Cartesian coordinates. And again, let's make the assumption here that my coordinates are straight. Okay, great. So if we draw our two forces, right? And our forces here, they're supposed to be equal, right? In magnitude. We'll call this one here force 2 and call this one force 1. Wonderful. Now, what else do we know about this problem? Well, the problem is telling us that the angle within here is 60 degrees, right? And if the angle within there is 60 degrees, then we know that the angle here is going to be 30 degrees, and we know that the angle here is also going to be 30 degrees. And if those two angles are 30 degrees, then we know that this angle here is going to be 60 degrees, and we also know that this angle here is going to be 60 degrees as such. Great. Okay, now let's go ahead and draw a free body diagram here, right? For our, just like as we've been doing, right? For force 1 and force 2, the components of force 1 and force 2, right? And when we do so, right? When we do so, we can get. Let me draw that a little bit neater. Right, we're going to have, again, bear with me, imagine those two y components of our forces are straight and equivalent. Wonderful. Now, when we do so, we're going to have the y component here for, oh, that came out a little too large. For force 1, this is going to be the y component. For force 2, this is going to be the y component, right? Now, here, this is going to be the x component for force 1. This is going to be the x component for force 2, as we see here. Wonderful. Now, in this problem, right, it's telling us that tension is consistent throughout the strap. Because tension is consistent throughout the strap, we know that force 1 is going to equal force 2. Now, because the two forces are equivalent to one another, right, and the angle within here is exactly going to be the same, we know that our force net x, right, it's just going to be the two components, right? It's just going to be for the x component of force 2, right? And the x component of force 1, and we know that that's going to be 0, right? The net force of the x components. Now, if that is 0, then we know that the net upward force of 7 newtons, that's going to be primarily attributed to the y components, right? The net force of the y components. Now, if we go ahead and rewrite the force net y, right, we see that's just going to be force 1 y, the y component of force 1, and the y component of force 2, and that's actually just going to be equal to 7 newtons, as we see there. Now, on the next slide, let's actually go ahead and add in a little bit of trigonometry here and see how else we can write the y components of our force vectors. And we know that the angle here is 60 degrees, right? So let's go ahead there, and we're leaving off right here with this equation right there. Perfect. Now, if we go ahead and we draw our, the vector components of either one of our two forces that we had there, right? So we'll just go ahead and we'll call this any one of our two forces there, right? Then we're going to have the following. Now we also know that this angle here is 60 degrees, right? Then we know that the y component for the force, we can also write it as such, sine 60 degrees, right? And there we go. And that's from our trigonometry review. Now, up to this point, if any of this, what I'm encircling here, seems foreign to you, I would recommend that you pause the lecture here, go back to the trigonometry review that we had actually covered in the translational motion lectures, and then come back. It'll make a lot of sense then. Okay, great. And the review isn't too long. Wonderful. Now that we know that, now that we found this equation here, right, what we can actually do is from here we can actually go ahead and apply that right to our right to where we left off in our force net y equation, which was right here, right? Furthermore, because we know that force 1 is equal to force 2, right, we can just go ahead, right, and write, I'll just show you 1 second here. This is going to be 7 newtons, that this we can just write as just 2f sine 60 degrees, right? And that's going to be equal to 7 newtons. Excuse me. Now, if we isolate for force, that's going to give us the force of tension on the strap. So if we go ahead and we isolate here for force, right, that's going to give us 7 newtons there, right, over 2 sine 60. Well, if you guys recall from our trig functions, I told you guys to really commit these ones to memories, right? The common trig functions, sine 60 is just going to be 0.86, right? Thus, if we go back, that's going to be 0.86. Now, once we go ahead and we equate this, we find that the force on the strap is going to be 4.1 newtons. There you are. So that there shows you a pretty good progression on how comfortable you should become with the